Hey everyone, in this video we're going to talk about what is a web crawler, how to do a system design for it, and what are the mistakes you should avoid. So what is a web crawler? A web crawler is a bot that systematically browses through the pages on the internet for purpose of building search indexes. For example, there are over 1 billion websites on the internet, but when you search using Google or Yahoo or any other search engine, it gives you the most relevant search result. How does that happen? It is because Google, Yahoo, and all these search engines uses a web crawler behind the scenes to browse through the data on the internet and builds a search index. So when you're searching for it, it looks up the search index and gives you the most relevant search results. It is also used to catch copyright violations and collect data to create web archives or train your machine learning models. For example, ChatGPT was trained on more than 500 gigabytes of text data found on Wikipedia, Reddit, Twitter, etc. The data collected via a web crawler can also be used for academic or market research purposes. There are 4 types of web crawlers. First one is focus web crawler. As the name suggests, they are very focused on certain use cases. For example, if you want to know what happened to a particular stock over the period of last 10 years, in that case, the crawler will only extract that relevant information for that use case. Second is incremental crawler. These crawlers are focused on incremental updates. For example, you already built a search index. Now it's just a matter of keeping it up to date. So these crawlers will only crawl the pages that have been updated since the last it was crawled. Okay, the next is parallel crawlers. It will run parallel threads to browse the web. The fourth one is distributed crawler. As the name suggests, instead of running the crawler from one location, you're distributing the processing from multiple geographical locations to crawl the web. That means one crawler can be parallel and distributed. These are not mutually exclusive properties. This means that a crawler can be distributed and also focused. While we're building this crawler, we're going to focus on collecting data for building the search engine. Let's talk about the functional requirements. As I mentioned earlier, there are over 1 billion websites on the internet. So not all the information is going to be relevant to us. So we want to be able to provide certain priority in our crawling process. If you look at the websites on the internet, it can have so many different types of content. For example, it can have a video, images, text, PDFs attached. But for our use case, we're going to focus strictly on text-based content. So we will only crawl HTML pages. Once we download the page, we want to preserve it. More than 30% of the content on the internet is duplicate. So we want to be able to identify the duplicates. Next one is the freshness of the pages. The content on the internet can be changing constantly. For example, news websites. Content on those websites are changing every single day. So we want our crawler to be up to date with those type of incremental changes.
Let's take a moment to talk about today's sponsor, Skillshare. Whether you're trying to learn a new programming language like Python, TypeScript, Java, or wanting to learn about databases, SQLs, or microservices, or DevOps, or in general wanting to learn about cloud services like AWS or Azure, there is a course available for you on Skillshare. So check out the link in the description below to get 30% off on your annual subscription to Skillshare.
Now let's focus on the non-functional requirements. Our crawler has to be polite, meaning when I'm trying to download the web pages from your server, I should not be sending so many requests at the same time that your server can crash. For example, this server is hosting a website, something like Wikipedia, where you have too many pages. Let's say it has 10,000 web pages. Let's say it can only support 1,000 requests per second. Now, our web crawler, which is a bot, it knows that this server has 10,000 pages and I need to download all 10,000 of them. If our bot makes 10,000 requests at the same time, it's going to cause this server to freeze, crash, and not serve its actual customer. This is called denial of service attack. Most modern applications have rate limitings in place. They will only serve certain number of requests per second coming from one requester. This is called rate limiting. So politeness is basically you want to build your crawler in such a way that it doesn't cause harm to other people's server. We want our crawler to support distributed crawling, and we also want it to be extensible for other types of use case. For example, today we are only downloading HTML pages, but later on we want to index images or videos. It should be extendable for different types of content. We also want this process to be robust because, like any other processes, there will be failures, and it should be able to handle the failures gracefully instead of having to re-crawl the entire web. Now let's talk about the API. First, resolve DNS service. It's a GET method. We will provide that a host name, for example abc.com, and it will return the IP address of the host. The next one is web page downloader service. It will be a GET method. We will provide it IP address and the path of the file we need to download. So this service will make a request to the host IP address that we provided, it will return the downloaded web page. The next is URL extractor service. This is also going to be a GET method. We will pass the downloaded web page to this service, and this service will extract all the links on that web page so that we can download the content for those links as well. So it will return array of links. Let's talk about capacity estimations. Total 1.13 billion websites on the internet, but only 20% of them are actively maintained. So 20% of 1 billion is 200 million active websites. A website can have multiple web pages. Your local grocery store can have a website with 2 or 3 pages. ABC News or Wikipedia can have hundreds of thousands of web pages. The number of websites that has large number of web pages in them will be few in count. Majority of the websites will have small number of web pages in them. So for our calculation, we're going to go for 100 pages per website as an average. Total number of web pages we need to crawl is 200 million websites multiplied by 100 pages per website. That means we have 20 billion web pages to crawl. On an average, a web page size is about 1 to 2 MB. If you exclude all the web pages or other media type of content, then the actual size of the web page is only about 100 KB. We're going to be downloading all of these pages and store it. So let's see, how much storage do we need? Size of one page multiplied by number of pages, which is 100 kilobyte multiplied by 20 billion pages. This is going to be 2 petabyte. If you want to understand the details of the calculations or how to easily do these capacity estimation calculations, check out this video here. In this video, when I was doing the capacity estimation, I have explained step by step in details how I did certain round-offs to make the calculation easier. Also add plus or minus 1 petabyte to cover any edge case scenario or unexpected situations. Take about 3 petabytes of storage to download all the text on the internet and store it. Let's look at our functional requirement and start our design. First one is priority crawling or seed URLs. Crawling the entire web, we want to give certain URLs a higher priority. So seed URLs is basically a list of those high priority URLs that we want to start the crawling process with. We should also choose the seed URL in such a way that our crawler can crawl maximum number of pages possible. We can choose our seed URL location based, subject based, or language based. Every country or geographical location will have a different set of popular websites. So you can choose the URLs depending on the location. You can also choose the seed URLs based on the subject. For example, sports, entertainment, education, etc. Choose the seed URL based on the language. Now let's go ahead and design the web crawler to crawl all the pages for one website. First, we have the seed URLs. These URLs can be stored in a file or a database. The next thing we want to do is to read the link from the seed URLs and download that web page. For that, we are going to use our HTML downloader service. Our HTML downloader will read the URL. Next thing, it needs to know which server do I go to download this web page. It will go to DNS resolver with the host name. It will say, here is the host name, which server do I need to go to download my web page. DNS resolver will give IP address of the server where the website is hosted. Once the HTML downloader received the IP address, it will make a request to that server where the website is hosted, make a GET request to download the file. Once the web page is downloaded, the HTML downloader will also try to render that page to make sure that there are no errors. In case the page is downloaded and if there is any error, which means you cannot even see the page, there is no point for us to store that page. So if it can successfully render the web page, it will store it in a file storage, for example, an S3 bucket. When we were doing the requirements, we talked about duplicate pages. More than 30% of the pages on the internet are duplicate. So we will go ahead and check whether the file that we downloaded is that a duplicate of an existing file. At this point, we're only crawling the web pages of one website, so it is okay for us to do a brute force comparison, do a character by character comparison of the files available in the S3 and check whether the file we downloaded is that a duplicate of an existing file. If the file is duplicate, then we will simply delete that file, and if the file is not duplicate, then we will notify our URL extractor. It will extract all the URLs from that web page and store it. You could store it in a separate database, but in this case, I am choosing to store it at the same place with the seed URLs. Let's go ahead and scale our design to crawl the entire web. So in this design here, we have one single server. We were crawling one website and this one server was hosting the website. So we were downloading all the pages one after another from this one server. If we are crawling the large number of websites, those websites will be hosted in so many different servers. We will not be able to represent every single website's host in this diagram. So we will simply change this server to internet. This current design, we are resolving the DNS multiple times, meaning every single page that we are trying to download, we are going to DNS resolver with the host name and asking them for the IP address. Now that process is not very efficient. Let's dive deep to understand how does this DNS resolution work. When you enter a URL in your web browser, that request goes to your internet service provider's DNS resolver. This DNS resolver will further make a request to your root name server asking, do you know what is the IP address of www.abc.com? Your root name server will reply back to your DNS resolver saying that I don't know where www.abc.com resides, but I know which server keeps the information for .com addresses, for example .edu, .org. So your DNS resolver will go back to the name server for .com and ask, do you know what is the IP address of www.abc.com? So the .com server will say, I don't know where is the IP address for www.abc.com, but I know that abc.com is hosted on Route 53. So go ask Route 53 what is the IP address of abc.com. Route 53 will reply back saying this is the IP address where abc.com is hosted. Route 53 is just an example in this case. It can be hosted on Bluehost, GoDaddy, or any other hosting services. Now your DNS resolver have the IP address. That IP address will be sent back to your browser and your browser will go to the host and get you the page. As you can see, we're making multiple calls to just get one IP address. We don't want to keep going through this process and get the IP address once and store it in a cache, and our HTML downloader will refer to that information from the cache. Now let's talk about the inefficiencies of our duplicate checking service. Right now, we designed this for crawling all the web pages of one website and we were doing character by character comparison. But when we are scaling to crawl the millions of websites, in that case, this brute force approach of comparing character by character to check for duplicate is very inefficient. Plus, it gives you incorrect results. So for example, if you have two sets of documents with exact same text and you introduce random spaces in between, you simply change a and the, comma, dot, comma, semicolon, things like that. In that case, your character by character comparison will show that these documents are different, but the meaning of the content in both the documents is exactly the same or similar. So brute force is not a very good approach. Plus, it is going to be very compute heavy and expensive. And it cannot detect the documents that has similar meanings, but the words are framed differently. So we're going to have to find alternate approaches. We can compute hashing by using MD5 or SHA, but because of hashing collision, it is also not the best solution. Probabilistic matching algorithms are ideal for finding near duplicate items. For example, InHash, SimHash, and fuzzy search are some of the ideal candidates in this use case. A lot of web crawlers use SimHash algorithm to find near duplicate pages. Now let's take a look back to our requirements and see how many items we have covered and how many more we need to do. Now let's talk about politeness. Politeness is basically don't cause harm to other people's server. We can do that by adding few seconds delay in our HTML downloader when we are trying to download the pages from the same server. It is one way to implement politeness, but when we are crawling billions of pages, adding few seconds delay between every download request will simply cause our crawling process to go for longer hours. We also need to choose the right algorithm for crawling the web. You can think of the web as in the internet as a bidirectional graph, where every node is a different website and these websites are interconnected. So we can traverse this graph either using breadth first search or depth first search. The breadth first search is the right algorithm in this use case for multiple reasons. One, most important information of a website is likely to stay closer to the root, meaning the home and level 1 pages. When we're using breadth first search, we're avoiding hitting the same server over and over to get the pages from that. Depth first search is a better algorithm if we're building a focused web crawler that focuses on the in-depth knowledge of certain topics. One downside to using depth first search is that we're hitting the same server over and over. Earlier, when we were talking about implementing politeness, we talked about adding few seconds delay between our two requests, that is downloading the pages from the same server. So when we say few seconds, what does that mean? Is it 2 seconds, 5 seconds, 10 seconds? How much delay do we need to add? That's when the robots exclusion protocol, robots.txt, comes into this picture. This is how the robots.txt file looks like. According to this, when MSN bot is crawling the BuzzFeed website, it should wait 120 milliseconds before crawling the two pages, and it should not crawl the files in following directories. Robots.txt reside under the root folder of the domain or subdomains. If it's available under a different folder location, then the bots will not follow the instructions in robot.txt. I have spent more than 40-50 hours of time over the period of last 4 months, so you can learn all of this information in less than 30 minutes. So if I'm putting 40-50 hours of time making one video, I need to know how many people is this video helping. Would you go ahead and hit that subscribe button here so that I know that the content I'm creating or the efforts that I'm putting into these videos are helpful to you guys. Now let's talk about priority. Priority should be calculated based on the freshness of the pages, traffic the site has, and how useful the content is. Let's take this for example. The class schedule page has important class schedule information, but that page is only updated once every semester, meaning 4 times a year. But there are 100,000 students using that web page. So considering that the information on that web page is more useful, have the student blog page. They have about 500 users, but that web page is updated every single day or sometimes even few times a day because students are posting on different topics. Now, in terms of the usefulness of these both websites, the college schedule has more useful information compared to a blog page where random students are talking about random topics. Now, let's also talk about abcnews.com. Now, let's say this news.com has 100,000 users. That page is updated every single day or a couple of times a day. It's based on the usefulness of the content, the number of users on that page, and how frequently the page is updated. That will decide what is the priority we want to give it. I am deciding the priority between the class schedule and the student's blog. I will give higher priority to class schedule website. If I am giving the priority between class schedule and news.com/today, I will give higher priority to news.com because the content on that page is updated daily, while the class schedule is updated once every 4 months. Freshness of the page is basically how frequently the page is updated. Our current design does not address politeness, priority, or freshness of the pages. So politeness, priority, and the freshness of the pages can be handled easily using this data structure called URL frontier. Okay, this is how the URL frontier will look like. The first component is priority computer. It reads the URL from the seed URL file or the database, whatever you're using, and then based on the list of predefined priority rules, it will compute the priority for crawling that URL. Now let's say we are working with 3 websites, abc.com, xyz.com, and hij.com, and based on the priority computer, our abc.com and hij.com have received the priority 1. So both these highest priority items will go into our priority queue 1, and our xyz.com will go into priority 2. The next component in the URL frontier is queue selector and router. So our queue selector will pick up the highest priority URL to crawl. In our case, it is abc.com, which is entered first in the priority queue 1. These are our politeness queue, and let's say Q1 is empty. So in that case, our queue selector and router will assign abc.com to Q1, meaning all the web pages that we will crawl going forward from abc.com will go into Q1 on the politeness queue. Now, in our priority Q1, we have hij.com, and in our priority Q2, we have xyz.com. But our priority queue selector will select highest priority URL. In this case, it is hij.com because priority Q1 has all the highest priority items. So it will now pick up the hij.com and assign it to Q2 on the politeness queue. All the pages from hij.com as a host will be added to this queue. Next, the queue processor will pick up the URL from Q1, check with the robots.txt for that website, how much delay does it have to add before it can make the crawl request to this web server. And because we will be doing this multiple times, we will cache all the robots.txt for all the hosts that we are currently crawling. All the items in Q1 belongs to the same host. In that case, we know how much delay to add between the 2 download requests we make from Q1. Let's say we need to wait for 3 seconds before we crawl 2 pages of host 1 in Q1, and we already made the download request 2 seconds ago, so we haven't completed the 3-second delay. In that case, our queue processor will pick up the request from the Q2 and make that download request, and then check again, has it already been 3 seconds? If it has already been 3 seconds, then it will go to the Q1, pick up the next item, next URL that it needs to download from that queue, and pass it to the HTML downloader. Because we are adding the certain delay between the 2 downloads from the same host, we will maintain a mapping table which indicates which queue is used for downloading the pages for which host. In our current design, duplicate detection service, let's say it has finished checking the duplicate for this file A, but now it needs to pass that file on to URL extractor service so it can extract the links from that. But URL extractor service is busy extracting the links from a previous page. So your duplicate detection service needs to wait until the URL extraction service has finished processing the previous. So we can have a queue in between the 2 services where duplicate detection service, once it's done detecting the duplicates, it can add the item into the queue for URL extractor service to pick up and process from the queue. We also need URL extraction service to do certain URL standardizations. For example, in one of the links, let's say HTTPS is missing or colon is missing or slash is missing. In that case, we want our URL extractor to be able to fix those URLs. We also want the URL extractor to catch for any loops, meaning if abc.com homepage is referencing to abc.com contact us page, and the contact us page is referencing back to homepage goes back to contact us page. So there is a circular loop between the 2 pages. And we want our URL extractor to be smart enough to know that loop and remove those circular references, so our crawler is not stuck in a loop trying to download the same pages over and over. one of our non-functional requirement is to make our crawler extensible for different type of use case. So let's say later on we decided that we don't want to just crawl the text-based content, but we also want to crawl images and videos as well. So in that case, we will change our HTML downloader to, download different types of content. And depending on the type of content, we'll store it in different buckets. All the video content will go in a different bucket, and all the image content will go in a different bucket. You can also have a separate bucket for audio files. I have not added that here on the diagram, but if you're crawling different types of music to check for copyright violation, you can also store it in a different file. Once we have downloaded all the content here, we can build copyright violation tools or search indexes or train our machine learning models on top of the data that we have collected here. One of our non-functional requirement is also for our crawler to be robust, meaning that in case we encounter any failure, we should be able to gracefully recover from that failure. Now here, considering the type of work we are doing here, that we are downloading all the content on the internet, we should not be having to restart the process in case there is a failure. So we should be writing our execution logs in some sort of log file. So when some failure occurs, we are able to start from where the execution failed instead of having to restart the whole process all over again. Once we have extracted the URLs from the page, instead of simply putting those URLs into the seed URL for processing, we should be checking whether some of those URLs have already been downloaded. So is downloaded service will check whether this URL was already downloaded. If that was already downloaded, we will not process that URL any further. And if the URL was not already downloaded, we will only then pass that URL and add it into our seed URL file. Now let's say you want your crawler to support all the types of content, all of these different types of content, but you want to, when you're starting the crawling process, you want to be able to decide if you're crawling just the text or just the videos or just the images. In that case, you can have a filter service. We want to archive the seeds URL and the log files for historical purpose, so we can track the performance of our crawler. It builds us historical data. We can build some insights on how frequently we are crawling which websites. This is how the structure of our S3 bucket will look like. We will store all the .com pages under one folder, then we will store the content by domain. So at a high level, this is what our design will look like. So in the past, a lot of you have asked me how you can download the content I'm creating, and with this video, I'm making that available for you guys. Check out the link in the description below. I also have had a lot of people reach out to me asking what tool am I using while creating these system design videos and what preparation material you should be using. So I have covered all of that in this video here. Go ahead and check that out.